how to graph quadratic equations from factored form. Let's look at some examples, and I'll use that to explain. Actually, let's first talk about what is factored form. We would often see factored form of a quadratic as f of x, remember that could also be y, is equal to a times x minus p times x minus q. And the x-intercepts are at the points p, comma, 0 and q, comma, 0. But it is in factored form. And then a, if there's no a, remember that a would be 1. If there's no number there, that a would be 1. So in the case of this f of x equals x squared minus 2x minus 8, because the focus of our our lesson here is not the factoring, but using factored form to get quadratic equation, I'm just going to go ahead and give you the factored form here. This would be f of x is equal to x times x. That's the, let's see, that x times that x, that's the x squared. And then I've got minus 8. And for those, we've got negative 4 and then plus 2. Because here that's negative 4x, that's plus 2x, negative 4x and plus 2x is the same as that negative 2x there. All right, so factored form is f of x is equal to x plus 2 times x minus 4. And the easiest thing that we get from factored form is the x-intercepts, because the x-intercepts happen when y is equal to 0. And so your x-intercepts are going to be something, comma, 0, where y equals 0, and then also something, comma, 0, where again y is equal to 0. And so f of x, that's y. And so if I set that equal to 0, I've got 0 is equal to x plus 2. Let's do this over here. 0 is equal to x plus 2 times x minus 4. Then for this to be true, either x plus 2 must be 0 or x minus 4 must be 0 through the 0 product property. And so here if I subtract 2, that cancels. X then is equal to negative 2. Or if I add 4, x is equal to 4. And so my x-intercepts are at negative 2, comma 0 and 4, comma 0. And my y-intercept, that happens when x equals 0. Always. Your y-intercept, x equals 0. And so if I go up here to the original, it's really easiest in the original. F of x is equal to 0 squared minus 2 times 0 minus 8. Again, x here is equal to 0. And so when x equals 0, that's when we're going to get the y-intercept. And so right here, this just goes away, and this just goes away, and we're left with y is equal to negative 8. Okay, direction of opening. If a is greater than 0, which is to say it is positive, then your parabola opens up. But If a is less than 0, that is to say if it's negative, then your parabola opens down. And in this case, I'll use blue. There's no number in front of that x squared, which means a equals 1. A equals 1, a is greater than 0, 1 is greater than 0, that's positive. That means this thing opens up. And so our direction of opening is up. And that's all we're asked for here in this example 1. Let's look at example 2. Example 2 is direction of opening. Well, this opens down. Again, if you kind of draw it this way, it might help you to remember. If your parabola looks like that, it's opening down. And then the vertex. Well, your vertex is the highest or the lowest point. In this case, it's the highest point, and so its x-coordinate is over 1, so that's -1. It's 1 to the left, and then it goes up to 9. So -1, 9 is our vertex. And then our x-intercepts are the places where it crosses the x-axis. And that would be here at -4, 0. And over here at 2, 0. So -4, 0 and 2, 0. And then the y-intercept, where does it cross the y-axis? Well, that always happens when x equals 0. And in this case, that seems to be at the point 0, 8. Now, factored form. They did not give us the equation, so we have to figure out what the equation is. We're not factoring the equation, but we can do this. So we're going to use those right there. And we're going to say, well, x equals -4. And then you kind of just go backwards. X equals -4, well, that's a plus 4 and plus 4. That means x plus 4 equals 0. So one of my factors is x plus 4. And the other is x equals 2. X equals 2, that's the other x-intercept. So we're using those. And if x equals 2, if I subtract 2 and I subtract 2, that just cancels on the right, leaving 0. And what I've got on the left is x minus 2. So my other factor is x minus 2. And now, you can take any point along the way. Like, for example, this y-intercept, if I got 0 and 8. And then just make note, oh, hey, this is x and this is y. And then keep in mind that what we have is y equals a times x minus p times x minus q. And then we're just going to substitute in values. Well, y is 8. So this is 8 equals. The only thing we don't know is a. So I'm going to write a. X is 0. So I'm going to write 0. And then the x-intercepts minus p. That's minus -4. So that's plus 4. And then x, once again, is 0. This time it's minus 2. And 0 plus 4, so I've got 8 is equal to a times 4 times -2. 8 is equal to a times -8. And then if I divide by -8 and I divide by -8, that cancels there. And a then is equal to -1. And so then I can go back over here and write a -1 for my a value, which is consistent with what we said over here, that if a is positive, then it opens up, but if a is negative, it opens down. And so when we got that a equals -1, that is consistent with the fact that this opens down. All right, let's look at the example 3. Once again, this is not factored form, so we would want to factor it. I'm going to go ahead and just write that in here. I know that this is x and x. And then I got -5, so I'm going to write +5 here and -1 here, and that would be factored form. And if x minus 1 equals 0, then x equals 1. So one of my x-intercepts is at the point 1, 0. And if x plus 5, the other factor, is equal to 0, then x equals -5. So my other x-intercept is at -5, 0. My direction of opening. Now, notice there is no number there, which is to say that a is 1. And that's positive. So this opens. That means that this opens up. So direction of opening opens up. All right. The vertex is a little bit, well, let's do the y-intercept. Y-intercept is at the point always 0 in x, comma something. Now, if I put 0 here, that's 0 squared, plus 4 times 0 minus 5. And all this is equal to f of x, which is the same as y. Then this term goes away because it's 0. This term goes away because 4 times 0 is also 0. And y equals -5. So my y-intercept is at -5. And then the vertex. Now, as it turns out, the vertex, this line that I'm drawing in here, is what's called the axis of symmetry. And it's always x equals some number. In this case, it's x equals -1. The same as the x-coordinate of your vertex. Always going to be the same as the x-coordinate of your vertex. And everything is the same distance. So if I go from any point, like here, for example, is 1, 2 points to a point on the parabola from the axis of symmetry. There go 1, 2 points to the other side, also on the parabola. So we can take the average. The x-intercepts the x-intercepts are at 1 and -5. So if I just take 1 plus -5 and divide by 2, that's -4 divided by 2, and that's -2. That means my axis of symmetry is that line. X equals -2. And then I know that my vertex is also going to be on that line. And so I can then just plug it back in. And you can plug it in up here in the original, or you can plug it in here. You can plug it into both just to make sure that that's what works. I think working it in the bottom probably a little bit easier. So I'm going to say, what is y? What is f of x if x equals -2? That's -2 minus 1 and -2 plus 5. So I'm taking this x equals -2 and I'm plugging it in here for x and then also there. And well, -2 times -1, that's -3, times -2 plus 5, and that's a +3. And so -3 times a +3 is -9. Which means my vertex is at the point -2 from the x-coordinate of the axis of symmetry and -9. So -2 and -9. So -2 comma -9. So my vertex, slightly off this graph, would be right down. Would be right down here. My x-intercepts are at 1, 0. So there's 1, 0, and then -5. So here's -1, -2, -3, -4, -5, 0. My y-intercept is at 0, -5. So go over here, 0, down, -2, -4, and -5 would be right there. Because I have the axis of symmetry, I can go 1, 2 units to the axis of symmetry, and then 1, 2 units on the other side, and I've got another point. So that's kind of a freebie there. And then I can graph this. It goes like this. And it should look the same on both sides. And if you wanted to know additional points, you can plug them in. Like I could say, well, what happens when x equals 2? I can guess that maybe it'd be up here by 6 maybe, but I can also plug it in. What happens if x is 2? Well, I would just say here's 2 and here's 2. 2 minus 1 is 1, and 2 plus 5 is 7. So f of 2 is 1 times 7, or f times 2 is 7. What that gives me is an additional point. It tells me that when x is 2, y is 7. And so I go over here 2 and up here to 7. And I'll do this in blue. Let's go green. Green. That point right there is 2, 7. And it's 1, 2, 3, 4 units. So go 1, 2, 3, 4 units. And over here is another point. And that would be at -6. It looks like -6, 7. Okay, that's how we do this. Work hard, you got this.